Welcome back for part 1B, computer concepts. So module 3, computer hardware. This is part 1B. Let's go ahead and look at what we're going to cover. In this short lecture, we're going to cover how computers represent data, benefits of internal, external, and let's not forget now, cloud-based storage, pros and cons of different types of computers, and then what we need to consider when we're purchasing our own computer or a computer. Now, before we get into this, we should understand what computers understand. And what's amazing is that everything we do in the digital world is understood through a series of ones and zeros. So 2 digits called a binary number system. Okay, each 0 and 1 is called a bit, as you see there, and 8 bits grouped together are called a byte. So when we start thinking about this, though, a byte is a very, very, very small piece of data, as seen here. So, by the way, 4 bits is a nibble. If you hear that, then you've watched this video if you get that on a quiz. A byte, as you can see, is 8 bits. Now we start getting into quantifiable file sizes. So 1 kilobyte is 1024 bytes. Okay, remember a byte is 8 bits, right? So 1024 times 8 is the number of bits represented in a kilobyte. Megabyte, then gigabyte, and as you can see, there's a trend here, whereas a gigabyte is 1024 kilobytes, okay, or megabytes, sorry, and so on. So a terabyte is 1024 gigabytes, and it's amazing that we're starting to see. I remember the first computer I worked on had a 10 megabyte drive, okay, and a lot of folks remember kilobyte drives. The first one I worked on was 10 megabits. We thought we'd never go through that. Now my current computer has 2 terabytes of storage. So as you can see right here, that's 2 or 2048 gigabytes of storage. And of course it goes up from there. One thing I would ask you to do, take a minute, go out and Google and see how many hexabytes are used by YouTube. So that's a pretty amazing number, astonishing number. Now, what did we do with these bits and bytes? Well, back in the day, we had a character system called ASCII, which was an 8-bit coding system. 8 bits are used to represent upper and lower case letters, mathematical operators. Now, if you notice on the right here, because our number system is either a 1 or a 0, there's 2 possibilities. That's representing the 2 right here. 2 to the 8th gives us 256 possibilities. Now, that worked for the English language because, you know, we had 27 upper, 27 lower. I'm pretty sure it's 27. It might be 26. Then we had a bunch of special characters, but we didn't exceed the 256 possibilities, which means that our coding system could represent everything we needed. It could represent a capital A, a capital B, a capital Z, a lowercase, an @ sign, all of the special characters we need, plus 0 through 9 for numbers. However, if we talk about like the Chinese language, there are a standard 2,000 characters that are used on a pretty regular basis. So ASCII did not work. Thus, came the event of Unicode. So 8-bit coding system. And if you notice here, I've shown you the example 2. So it used to be 2 to the 8, right? Now it's a 16-bit coding system. 2 to the 16 gives us 65,536 possibilities. And this literally can represent every character in every language. So we suddenly have the ability to use computers much more efficiently. Now, a little bit more detail. In the previous video, we talked about some basics of drives. Now I want to get into some more detail. So when we talk about drives, first of all, internal hard drives are secondary storage. The standard hard drives we used to have were magnetic hard drives called SATA, serial ATA. And you see an example here. We added more platters. We ended up with more storage. We also increased the technology so that we could put more ones and zeros on this drive. So today, these serial ATA drives are still used and can represent up to about 16 terabytes of data, meaning you could go out to Amazon and buy a 16 terabyte drive. The challenge with serial ATA is it's rather slow. Okay, its read-write speeds are rather slow. Thus, we started taking that flash memory, combining a bunch of flash memory into an array of flash memory, creating a solid state drive. So solid state drive, again, is secondary. It's an array of flash memory. Standard sizes there, you know, are 128 gig, 256 gig, 512 gig, even a terabyte. Those are pretty standard. And we can see those up to multi-terabyte when we get into server uses for secondary storage. External hard drives, I've got an example of a modern one here. This is a modern external hard drive. It's an array of flash memory, so it's called an external SSD. Now we can get external spinny drives too. They tend to be pretty inexpensive. For example, $125 at Costco will buy you up to 8 terabytes, 8 terabytes of external storage. Usually through a USB. Of course, the USB, the faster we get that USB connection, the faster we can read, write off of the drive. Now, two things that get in the way. The connection to the computer, USB, if we're doing that through USB 3.0, we're only transferring theoretically 5 gigabits per second, okay? Gigabytes per second. However, down here, because of these faster speeds, we're getting into the 500 and upwards of 1,000 with a Thunderbolt connection. Thus, almost instantaneous that we can transfer, say, a DVD quality movie. Optical CDs, the things we need to know about that is, again, they're secondary storage. They run off optical media, meaning there's a laser that changes the direction to represent a 1 and 0 on there. When we talk about CDs, you know, we're talking about storage in the way of about 700 to 750 megabytes on a CD. Then we jump up to a DVD, a single layer being 4.7 gigabytes, double layer about 8.4. Then we jump up into Blu-ray discs where we can see upwards of 50 to 200 gigabytes, okay, stored on those. Now, the idea is that those technologies are declining as it pertains to storage because we now have this great thing called cloud storage. So stores electronic files on the internet, not the local computer. The cool thing about this is then those files are available cross-platform. Meaning, let me give you an example. Google Drive is available on my Mac. It's available on my PC. It's available on my Linux device. So consequently, I can store all my files in one place and access them over many different platforms or computer technologies, as we'll talk about. Google Drive is pretty inexpensive. You can get about 100 gigabytes for $1.99 a month and store everything out on the cloud. Now let's be careful here. We're going to talk about backups, and cloud storage is not necessarily a backup. Okay, what I mean by that is, yes, you can put your files out in the cloud. You can pretty much expect those to be more reliable, if you will, because companies with a lot of technology are storing your files. However, if those files are to get encrypted because they're connected to your computer and they're to get encrypted by, say, ransomware, you can lose stuff that is on the cloud. Now, cloud technology providers, storage providers, are creating technology to see if that's happening and stop the encryption, but you may lose valuable information as we talk about storage. So, different types of computers. Desktop computers are a great example. Down here is a desktop. What we tend to see with desktop is that they're more powerful. They're much more easy to expand, meaning we can much more easy install additional RAM, install peripheral devices, install a custom video card, for example, custom cards that meet our needs, okay? That's not the case when we get into other computers like all-in-ones, etc. So because we have this big tower, a little bit hard to see, here's an example here, the tower gives us room to expand. The larger tower will have more PCIe slots in them, where we can add additional what's called expansion cards. So a sound card might be an example, or a video card might be another example of things that we want to expand. We want better sound than the default motherboard gives. We install a sound card, okay? Now, let's not confuse this. Just because this CPU, Okay, well, sorry, not CPU, the computer box. The CPU is inside. The computer box sits behind the monitor. This is not an all-in-one. Here's our first example of really an all-in-one. It was when Apple took the motherboard and put it behind the monitor. It was a one-piece unit. The entire computing device was in that unit. So we had our output of the monitor. We had all of our processing, and our RAM and our storage was all behind the monitor. And the only peripheral devices we had were a keyboard and a mouse. Okay, so those are all-in-ones. And that would be an example there. Moving on to mobile devices. When we talk about mobile devices, we're talking about devices that are much more easily transferable. So today, a lot of the computing devices we use, okay, there are some all-in-ones that are definitely portable. Tablets, we think about, mobile devices. Desktop computers, not so much, right? So these are portable or handheld computing devices. Your smartphone is a mobile device. Your tablet, say your iPad or your Galaxy, are mobile devices. When we get into these kind of mobile tablets where we have an external keyboard, maybe a pen, again, a mobile device. They may come with or without. They're convenient, but of course, they're not upgradable. Now with a laptop, we might be able to increase the RAM in the laptop, and we might be able to change out the hard drive. But when we get into these components here, very difficult to make upgrades, and people don't tend to upgrade. So if we're going to buy mobile devices, we want to make sure we get all of what we need ahead of time, and I'm going to show you how we do that. Okay, so when we talk about computing devices, the first thing is an operating system. A computer without an operating system is essentially a boat anchor. It's a very expensive boat anchor. The first piece of software that needs to be installed is the operating system. And standard operating systems that we see are Windows. Today, Windows 10. In the server, we see Windows Server. We'll talk a little bit more about that in later videos. We have Mac, which is the Apple proprietary operating system. And then, of course, in the smart devices or portable devices, we're now seeing things like, and laptops, we're seeing Chrome OS, that's Google. We're seeing a lot of implementation of Linux, not as much Unix, but Unix and Linux are what's called open source. They're non-proprietary. They're not owned by a single entity, and they're updated by anyone who wants to program. Google Android, which currently I just updated my phone the other day to Android 10, and then Apple iOS, which I think just released, let's see, it's the iPhone 11 just released iOS 13. When we look at the device that we're going to use, we need to look at things like the amount of processing power it has, how much memory it has, how much storage it has. For example, most of you don't need a computer like I have, which has 2 terabytes of storage. However, I do a lot of virtual machines, which means I have many operating systems installed on my one computer. That means I need the storage for when I bring up those virtual machines to have them run. Okay. Today, I think, Windows is using about 20 gigabytes on my computer. And then I have different versions of Windows. I have different Linux versions running. I even have a base Android system that runs a virtual machine on my laptop. I have servers that run and email servers so that I can demonstrate technologies. Most of you aren't going to need that amount of storage. Also, in creating videos like this, a 4K video of 15 minutes long is about a 350 megabyte file. So those add up pretty quick when you figure I have over 450 videos that I've created. We have to look at what kind of ports they have. USB, does it have Bluetooth? Do we need an optical drive? Today, most definitely mobile devices, even laptops, don't come with optical media. We can get them as external if we need them. Now, depending on your use of computer, you might get 3 to 5 years out of a computer. Because I teach computing, because I teach information technology, I tend to update my computer about every 2 years, okay? Because I do need the latest and greatest and can use what's there. When we look at form factors, we've talked a little bit about this. We're looking at desktop, laptop, tablet, smartphone, ultra thins, which are highly portable, so they're much more mobile. An ultra thin would be a computer like this. The smaller the form factor, the less technology we tend to get in the form factor. Meaning we're going to talk about 2-in-1s, which are laptop computers where we can fold back or detach the keyboard and other devices and use it as an independent tablet. That works really well. However, we're not going to be able to get the processor and the memory and the storage that I have within my bigger laptop because there's room for it. Then we look at peripheral devices, keyboard, mouse. We'll go into these into detail. Input and output devices that we need, make sure peripherals are compatible. So we want to make sure that a peripheral like a hub where we could connect more things in, we have to get a hub that's specific for Windows versus a hub that is specific for Mac. So the transfer technology or the protocols are different, and we have to make sure peripherals support our base operating system. All right, that's it for part 1B. Next time we'll hit part 2, and we will look at input devices in detail, output, and how to install computer hardware. Until then, take care.